see. Okay, I was thinking earlier, it occurred to me, I haven't actually shown you how effective the exit coil actually is. And I thought, did I make a video about that? And I think, no, I didn't. So hang on, let me just get the camera set right. I'm trying to set the camera as far back as possible so I can get the oscilloscope in. Oh shit, I'm looking at this. This is delayed, so everything's right. I'm hoping that we can get the RPM meter in and the oscilloscope in. Right. Oh, sorry, you're going to see echoes because I'm looking at the delay. Right. Okay. So the RPM meter is over there in the red digit. I hope you can see that. Actually, my resolution's really crap. Well, I've got the resolution set out. I want 360. I want 720 just to check this out. Well, I'm hoping you can see that. Oh dear, let me see. Oh, hang on. I'll go and fetch the chair. Oh. Yes. What I do for science, I don't know. Right, so if I bring this a bit closer, you should be able to see a bit better. Right. If I bring the oscilloscope here. Right, I'm hoping you're able to see that okay. Right, let me just well, I'll leave the camera a minute because I'm looking at this freaking delay. Yeah, I think, oh, now you can't see the scope. Oh, wonderful. Oh, I'll tell you what, I'll move it a bit, hang on. Let me just move it over a bit. Right. Oh, it's because I'm filming from the camera. I don't have many cams, so I can't preview. Right, so well, all that really matters right now is the RPM meter. Let me just get to this box to put the scope on anyway. Should make a big difference. Right, that should be better. Temporary. Right, that should work. It should do. If it doesn't, I'll give up. Right. Right, let me just move these wires out there. Right, this is the voltage going into supercapacitors when it's turned on. And this is the current that goes into the supercapacitors when it's turned on. Well, I've got it on the 20 amp. Let's just move some junk out of the way. Right. So what I'm going to do is I'm going to start this up. I'm going to let it get up to speed, and you'll see how much current is going into supercapacitors on this meter. The voltage that's going into the supercapacitors will be displayed on the black meter. Now, when I disconnect the exit coil, which basically is a drag cancellation, and this is my new inductor I made, and I did a separate video about that earlier today. Now, these two wires here, this one and this one, both go down to my drag cancellation coils, which I've mounted down here now because they're actually on the pull. They're actually in pull, so they're actually pulling. As that, the generator coils are both underneath these concentric magnets. So there's generator coils down there and down there, and basically what happens is that they're in series with this circuit. So the actual power from these two coils comes into the circuit board, runs through my delay line circuit on the top one, oh, it's that one, the top wire, this one, runs through the top part of the circuit through the delay line circuit and the capacitors and everything, and the bottom wire, which is from this side, goes through the bottom section, goes through these two LEDs and a 10 ohm resistor and towards the triac, which I tune and trigger to adjust the drag cancellation, which goes to the exit coils down here. Now there's still a circuit coming in all the way around. There is still a circuit charging the capacitors and the inductors and everything else, which completes the circuit for the generator coils. So even if I remove the wires that come out for the drag cancellation circuit, the drag cancellation coils down here, even if I disconnect them, the circuit is still powering, charging the supercapacitors. So what will happen when I disconnect the wire that goes to the exit coils simply is what you're going to see. So I'm going to demonstrate what happens, because I don't think I've done this test. Right, let's get things running. Let me set my current to a stable amount. I'll set it to 1.2 amps. We're at 14 volts. Oh, this battery's dying on me now. I shall leave it. This battery's a bit weak. Right, I'm just going to let it pick up speed. Right, there's the oscilloscope. The blue trace is the new waveform that's created by the new delay line. Now at the moment we're delivering 200 milliamps into the supercapacitor circuit. Oh, what's happened to my meter? It's not. Hang on, wires have come off somewhere. Right, that's it. Right, that's the voltage that's going into the supercapacitors. It's at 5.63 and climbing. Now I want to get the speed up, so what I'll do is I'll disconnect the current so it'll pick up speed and we'll get stabilised quicker. Right, as you can see there's no circuit, so the LEDs have gone out. Right, I just wanted to get the speed up so it'll settle quicker, otherwise I'm going to be waiting for 5 minutes for it to pick up speed. Right, we're generating 210 milliamps right now into the supercapacitors. Now, to show you how effective my exit coil is, I'm going to disconnect this one wire that goes down to these coils down here. Right? We're stable, look, 5,130, 210 milliamps. Now watch what happens when I disconnect the exit coil. I have to put my finger on it. Oh, hang on, I'll use this. Otherwise I'll pull the board off. Look at that. We're generating 240 milliamps, which is dropping. Look at the RPM. Look at it drop like a stone. That's how effective it is. It's still dropping. Let's plug the drag cancellation coil back in. You see it's picking up speed again now. I'm not going to mess with the tuning because it takes me ages to get set right, as you can imagine. But you could obviously see the current changed when I did that. Obviously we had a bit more current generated because less power was being used by the exit coil, because some of the current is being used to cancel the drag. So when I disconnected the drag and the drag coil, the anti-kick drag coil, when I disconnect that, that extra power will go into charging the battery, the supercapacitors, which is why it went up. Let's just do that again. If I can get it, I can't see the wire. Disconnected, but it slows down. And as it slows down, we're losing. We're drawing more current on the input now because we're slower, but we still have the same output. But we're actually drawing more current because it's running slower. You see, but because we're running faster when I plug the exit coil in, the initial current will drop, but it will pick up speed and it will deliver the same current again. So we're actually gaining because we're using less power on the input to drive the circuit, to drive the unit. That's the whole point. It's minimizing the amount of power it takes to drive the unit. Every penny saved is a penny earned, as they say. So anyway, that's all I really wanted to demonstrate on this video. And it's going to take a while to charge them supercapacitors up. They're actually, for the solar battery up, they're actually over there. So yeah, you get the idea. I've got a pluggable capacitor just here. Take that out, it should pick up a bit more speed even. But we lost a little bit of output. We've got an extra 10 milliamps with that capacitor in. But it slows down a bit. So it's basically robbing Peter to pay Paul, basically. We have to create a balance, whereas we're allowing so much power through to the drag cancellation coil, but when we do that we gain speed. So obviously if we gain speed, we're using less power to drive the circuit, but we're still getting the same output. So that's a benefit. Now the only other thing I need to deal with is the other drag issues, which is to do with wind resistance, air friction, and in the unit itself. And I'm thinking about actually enclosing the unit inside a vacuum, the actual rotor assembly inside a vacuum, having the bearings and the rotors with the magnets inside a tube, an existing tube that's on the unit, but making it a vacuum inside so there's no air friction, and using a magnetic coupling on a thin disc on the outside, spinning that with the motor to turn the drum inside. Then we'll have less wind resistance. The actual disc itself won't offer a lot of resistance because it's a small footprint. So anyway, that's what I'm thinking about. I haven't decided on doing it yet. I'm thinking about it because it's more money to spend. It means I've got to buy a vacuum pump, I've got to build more things to go on the outside. But you see, there's so many more things I can do with the existing build in improving that first, so I don't have to rush into the vacuum idea, but it's just an option and an idea to try out at some point, and I could do it later, I don't have to do it now. So anyway, you've seen the effect that has. As regards tuning it, when I unplug the exit coil, that wouldn't do a damn thing, because I'll tell you why. The tuning part of the circuit is on the triac, on this triac down here, and all that does is trigger when output from this circuit goes to the exit coil. When the exit coil is not connected, this is not doing anything, so adjusting the trimmer wouldn't do a thing, because it's no longer going anywhere. The exit coil is connected to these points here, so also changing the inductance of the coils themselves wouldn't make any difference if I adjusted that, because it's not going through to a load on this end. All that's happening is the series circuit is still completed through the LEDs and the resistor down here, through the choke, back to through the generator and to the actual output, which is on the other end. So that's why there's no point in me messing about with the tuning, because it wouldn't make a damn bit of difference, because there's nothing. The only thing that the tuning does is tune the exit coil itself, but when it's not present, it doesn't do anything. So, but you get the idea. So anyway, that's that. This wire is rubbish. It's got a bad connection. This wire's warm because there's the plug itself. It's a crimped one. I need to sort this plug out. I'll probably do that in a bit as well. Yeah. So anyway, that's all. Just a little. If I can get the phone out of here. Come out. I can get it out. Oh, got you. Come out, you bugger. Right. So, what have we done now? Oh, I hate the. Right. So anyway, you got the idea. So I'm going to see what's happened on the screen now, because I went and knocked the phone. Oh, my screen is popped. Oh, it says I'm still alive anyway, I think. Anyway, that's it.